This particular video is the second installment in complex fractions. This one is going to deal with denominators that are not necessarily monomials. Okay, they could be binomials, or I can have a binomial in a denominator, stuff like that. Okay, so this is going to be the next installment. So remember last video I talked about complex fractions and I need same denominators in order to do the shortcut. Well, even though I have a different looking fraction here, complex fraction, I still have to do the same thing. Okay, then the shortcut will still work out and we're still good to go. So if I look at this particular problem, I now have three fractions, right? I have the 5/3, I have the 2/5, and I have the 5/2 there. There's technically three fractions within this single fraction. I still want to do the same thing. I still want to find a common denominator between now all of my denominators, so between all three of them. So I have the 5, the 2, and the 3. What is the smallest number that they can all go into? Well, if we know multiplication, that means they all go into 30. Now again, if you don't quite know multiplication skills, or you're having a bad day or whatever, you could just multiply all the denominators together and you would still get a number. It might not be 30, it might be bigger than that, but you can still use it, okay? But in this case, if I multiply 5 times 3 times 2, I end up getting 30. So how did I go from 3 to 30? I multiplied by 10. So now my new fraction, my new numerator in my fraction is now 50. Still have my big fraction there. And then now I have my individual fractions in my denominator. This 5 right here made 30. How? I multiplied by 6. So this becomes a 12. It becomes a 12 because 2 times 6 is 12. This 2 changes to a 30. What did I multiply? I multiplied by 15. So 5 times 15 is 75. Okay? So now if I look, I have same denominator, and same denominator. So now let's do the same exact thing I did in the last video for the shortcut. I take the numerator, I divide it by what's left on top, and then I now have to simplify. 50 over negative 63. Nothing can be reduced, so my answer is going to be a negative 50 over 63. Some of you might be thinking, well, how come my negative went to the top? Okay, technically, when I have a negative fraction, so for instance, if I have a number divided by a negative number, that's the same as taking the number on top, making it negative, and making the bottom number positive. But that's also the same as putting the negative out front of the fraction. Okay, they're all the same thing. The first one here is what we had up here. This doesn't look good. So please, please, please try to write it like one of these. So I ended up writing it like that one there. Okay, so please, please, please write it like one of those. So answer negative 50 over 63. Okay, let's look at this one here. Again, I need the same denominator. So I have a 3, a 4, and a 4. What number can they kind of change to be? They can both be changed to a 12. So since they're all now a 12, 3 times what is 12? That's 4. So this makes a 16, right? Because I gotta multiply by 4. 4 times what is 12? That's 3. So 3 times 3 is 9. 4 times what is 12? That's 3. So 3 times 1 is 3. So now all of my denominators are the same. 12, 12, 12. So I can cancel them out and get rid of them. What do I have left? I have 9 plus 3 over 16, which is 12 over 16, which can be reduced by 4 to get 3/4. And that's your final answer for this one. Now this one looks a little different. The reason why it looks a little different is because the 25 doesn't look like a fraction. Well, when this happens, regardless of where it is, remember that there's a 1 underneath it. You need to account for that. You can't just say, oh, I'm good, I got 25. It ain't gonna work that way. You need the denominator that is equivalent. Okay, so we need the 1 there, and then we need to change them. So my denominator of 5, 4, and 1, what number am I going to use? Well, I'm going to use the number 20. So 1 times 20, so then 25 times 20 gives me 500. 5 times 4 is 20, so then 1 times 4 is 4. 4 times 5 is 20, so 3 times 5 is 15. Now, because my denominators are the same, 20, 20, and 20, my numerators are going to be 4 minus 15 over 500. Let's finish it up. That's negative 11 over 500. I can't reduce that at all. I am done. Go ahead and do this particular problem. Again, pause the video and then hit play once you have it done to find out if you get it right or wrong. So this particular problem, technically this 12 is really a 12 over 1. So what is my new denominator? Well, this is 25, 25, and 1. So my new denominator has to be just a 25. So because I didn't change this one, and I didn't change that one, it's still 9 plus 12. But I did change this one. I multiplied by 25. So that gives me 300. 12 times 25. Because now my denominators are the same, I get 300 over 9 plus 12, which is 300 over 21. Now some of you might be like, I'm done. No, you're not. You have to divide by 3. See if you can reduce. That's 100 over 7. Now I'm done. Okay, let's look at this particular problem. Now we got some variables. Again, we're going to do the same things as before. We want to make sure our denominators are all the same. Remember, this x in the denominator here actually has a 1 below it. So let's find a common denominator that I can use. I have a 4, an x, and a 1. Well, they all can go into 4. And because I have an x to the first power, they all need to be with an x. So 1 times 4x is 4x. So x times 4x is 4x squared. 4 times x, so x times x is x squared. X times 4, so 4 times 4 is 16. So they have the same denominators, 4x, 4x, and 4x. So I get x squared plus 16 over 4x squared. Now, am I right? Am I wrong? Am I done? I don't know. Okay, so I can try to factor this. Okay, there's nothing they have in common, like they don't have a 4 or a 2, but I want to see if I can do an x. That's 16 and that's a 0. There's no numbers that can go here that will give me 0 when added but multiply to 16. Because the only ones that would work are 4 and 4. They multiply, but they do not add. Okay, they add to 8. So that cannot be factored. Therefore, your answer is x squared plus 16 over 4x squared. That's your final answer. Okay, let's do this particular problem here. Again, I need a common denominator. So what is it? Well, I have an a and a 5, so that means hopefully by now we know that we can just do 5a as my common denominator. So because that's 5a, this has to be an a, and then this has to be an a squared, because I multiplied by a to get the 5a's. And then I multiplied this a by 5, so this becomes a 20. So now I can rewrite my answer as a minus a squared over 20. If you want to go one step further, you can say, well, this is really a times 1 minus a over 20, but I can't reduce anything. So you can leave your answer this way if you wanted to go that one step further, but remember, you can also leave your answer this way as well. Both of those are acceptable. They're both right. Okay, go ahead and try this particular problem. Again, pause the video, see what you get, and then hit play to make sure you're on the right page. So I want to find a common denominator. First thing, this x, so I'm going to put a 1 underneath it. And then I'm going to make my kind of new fractions where I'm going to put them. If I see my denominators of 5x, 5, and 1, hopefully again by now you know that you get a 5x as your LCD. So 1 times 5x, so I got to multiply 5x, that's 5x squared. 5x here, and that 5x are the exact same, so that 16 stays the same. This 5 to the 5x I multiplied by x, so this becomes an x to the third. So now let's finish. My denominators are all the same, so numerator over denominator. I cannot reduce anything, therefore this is my solution. That concludes this video. We're having not monomials in the denominator. If you need help with more binomials and trinomials in denominators, please again watch the next videos.